Good morning, everyone. My name is Chethan. I am from Institute of Aeronautical Engineering College. I am from CSE department. My roll number is 2195180-532. My TechTalk Ppt presentation in Java subject. My topic is modern file input or output with Java. What are the modern files? How the input and outputs will be given in the Java language. Okay. First one is, one reason why it is popular is because its rich library offer powerful and concise APIs to solve most of your programming needs. However, there are a few areas in which older versions of Java weren't quite up to scratch. One example of this type of headache for developers are traditionally in IO APIs. There have been several attempts to resolve this issue, leading to several different IOs, input and outputs, APIs. There are many files like the first file Java one is the file input stream and output stream APIs, and the next one is Java the readers and writers APIs, and next one the new input and output NIOs, and next the path API NIOs. Next, the original Java IO files, java.io.file class in particular had different significant limitations. Those limitations are it did not deal with the file names consistently across all platforms. Second one is it failed to have a unified model for file attributes. And third one is it was difficult to use it to traverse directories. And fourth one is it didn't allow the use of the platform specific features such as symbolic links. First, file attributes. What is the file attribute means? Each file system has its own set of attributes and its own interpretation of what those file attributes mean. Fortunately, modern versions of Java support file attributes across the many file systems via implementations of the file attribute view and the basic file attributes interface. By the way, you need to take extra care when writing file system specific code. Always ensure that your logic and expectation handling cover all the cases where your code might run on a different file system. Listing 1 manipulates the file permissions of a text file simple.txt. This is located in the user's home dictionary directory. The user means Ben wants to grant other in the same group the permissions to read the file. The system specific postfix view class lets you add the read only permission to the group. And there is a code, we can look at it. The code goes here like this. Import Java enavo.file.attribute. Import static Java enavo file.POSIX file permission group read. Try. Where team list path.off. POSIX file attributes address. File.read attributes team list postfix attributes class. Set postfix permissions. POSIX file permissions. Where owner equal to attributes.owner means attrs. We can shortly write it as attrs. Next, variable permissions equal to POSIX permission trusting. Next, system.out.format is percent declaring the address of the various attributes. And next, owner permissions. And next one is POSIX permissions add in the group. And next, by using file.set postfix permissions, we can read out the team list POSIX permissions, etc. So this is the code goes here. And next, code begins by importing some attributes classes and a POSIX file permission constant, and then gets handled for the sample text file, sample.txt.file. Using a helper method from the files, it gains access to the POSIX file attributes, and subsequently to the POSIX permissions attributes. The code echoes the current permission and then adds the new group, read the permission to the file. The next one is symbolic links. What is a symbolic link? Apart Apart from the types of the basic attributes, Java has also an extensible system for supporting special operating system features. I will showcase this support by walking through an example of the symbolic link support. Symbolic links means, shortcutly we can write it as symlinks, are available in many common operating systems including but not limited to Linux, Mac OS and Windows. And next one, a symlink can be thought of as a pointer to the another file or directory, and in the most cases these links are treated transparently. For example, using a symlink to change to a directory will put you in the directory that the symlink is pointing to. However, some software such as backups utilize needs to discern and manipulate symbolic links as a special case. NIO2 allows this. Java support for symlinks basically follows the semantics of the Unix implementation. The following example examines and follows a symlink for option maven that points to the specific directory. For Apache maven, the file system looks the following. And here another code, path equal to path.of. Try if files.iss symbolic link path. Path contains file.read symbolic link. Path target equal to path.tolertorial path. System.out.println links contain system. System.out.println links target. Various attributes equal to file.read attributes. System.out.println attributes. Catch IO exceptions. e.print stack trace. The code starts by checking whether the path is a symlink, and if so, it reads the content of the symlink. This is expressed as a path object, but it does not point to the target of the link. In this case, content contains the single path component Apache Maven, which does not point to the actual physical path. Instead, to access the file, use to real path, which returns a path that is fully resolved path, physically path. This discussion covers only symbolic links. In Java Paths API, multiple hard-linked files, assumed that they are supported by OS, are not distinguished. For example, all hard links are treated as equivalent. Next one is dealing with the directories of NIO2. How to deal with the NIO2? Let us look. Java's ability to navigate directories was given a major overhaul in NIO2. The addition of the new interface and the implementing class allow you to perform the following types of operations. Iterate over entries in a directory. Deal with large directory structures. Filter entries using regular expressions and MIME-based content detection. Perform recursive move, copy, and delete operations via walk file tree method. Shows a simple example of how to use a regular expression pattern match to list all the Java files in project directory. Find the matching files. Here is another code how to find the matching files. It is variable.directory path.of users benefits projects open JDK. NS directory stream path stream file.new directory stream. For path entry and stream, system.out.println entry dot get file name. And here catch IO exception E. Print stack trace. And next one is the code begins from the base path of and the construction director stream. It confusing because of the despite the name, this class not dependent the stream interface. Instead of the class is intended to the used of the filtering tools, the code iterates over the entities that have been found in the print each one and out. Show that the APIs used the dealing with a single directory, but there is no problem. Will you see if you run the code? If it returns no result, this is because the code will look only at the single directory, which is not used. Very helpful use, very useful. What can I do? It, if you do not need to recursively filter across multiple directories. For example, Java sources files typically sit in the package structures, and the OpenJDK source is not stored in the main directory, but further down in the file system in the Java base. Thus, the source file exists in the multiple directories at the multiple levels of the depth in the file system. You need to way to handle this layout and recursion that walks the directory tree in a natural way to achieve this. Here another small code like file.walk files tree. Providing the starting directory is easy, but about the implementation of the file visitor interface, unfortunately, there is not as simple as the providing a lambda. In fact, you need to implement at least 5 methods. 5 methods are like file visit result, pre-visit directory, tdirect. Second one is file visit result, pre-visit directory failed. Third one is file visit result, visit file, tfile, base file, attributes. Fourth one is file visit result, visit file failed. Fifth one is file visit result, post visit directory. That looks like a fair amount of work, but fortunately, the API supplies a default implementation, the simple file visitor. Carry on from the example in listing 3 of finding Java source in a file directory. You can now list Java source file from all the directories and sit underneath. Listing 4 demonstrates using of the file walk file tree method. Various standing directory path.off file.walk file tree. Public class find Java visitor extend simple file visitors. Public file visit result visit file path file basic file attributes. If file is not equal to null and attributes are not equal to null, then if file gets name string ends with Java. System.out.print we can use file name and finally return file visit result continues. You start with creating the path object and then call the file.walk file method, pass in the find Java visitor which is an implementation that extends the simple file visitor. In other words, let the simple file do mostly work of the transfers and the directories and so on. The only code that have to return when you override the first file method. In this method, you need to write some simple code. If a file ends with Java and echo, its name to stood out if it does. And next one is watch server and file change notification. The Java APIs provide the ability of the file directories. This is done through watch service class in Java and IO file. This class uses VM management client threads to keep the eye on the register files and directories for change, and it will return an event when the change is detected. You need not be manage these threads. We can see the code here, which is going for the watch file. Initial setup involves getting the default watch service and handle on the Ben home directory. The next is the registration of the modification. Watch on the directory, then use the safe shutdown pattern, usually seen with the volatile Boolean variable shutdown. The take method on the watch service boolean and a watch key becomes available. As soon as key is made available and code polls that watch key for a list of watch event objects. Next, temporary files. Helper methods in the file class include capabilities to create and work with the temporary files and directories. Note that Unix-like operating system can clean up temporary working areas such as temporarily automatically. The simplest way to create the temporary file is path p. P equal to file dot create temp file. Code to work with p. After you finished with file, by default you need to delete it. This quickly becomes tiresome, but fortunately the API has simple solution. The file class provide convenience method for tasking such as an input file stream, a path. The helper come with the possibilities of the specifying option for how the file to be opened and closed, such as the following. This is the path. As you can see, temporarily and automatically delete the file with which will occur when the inner try block is completed. This is a much leaner and safer requirement manual cleanup and demonstrate a nice interaction with the try with new source language feature. Unpacks jar file and temporary directory use not temporary directory handling, but in zip input stream. We can see another code how this will go. And finally, the conclusion. In this article, you need to develop deep into the Java, NAO2 API, and some techniques that allow you to perform platform, platform specific features and transfer structures and watch for the changes. They are broadly high-level operations. What I have done so far is to discuss the low-level, high-level performance features in the modern Java input and output. These APIs will be subject to the next article in the series. Thank you. I hope everyone liked my PPT presentation. This is Chetan signing off.